So, thanks for coming down, everyone. So my name's Neil. Today I'm going to be talking to you about democratizing your data using Splunk. A bit about me. I've been Splunking since 2008, quite a while. The largest Splunk implementation that I've worked on is about 3 terabytes a day, with 1.2 terabytes searchable. And in terms of using Splunk, I would say for this particular implementation, we were able to successfully federate to about 900 users-ish. Other than Splunking, my interests are sort of guitars and the occasional uke. So what is Splunk? So it's actually quite a difficult sort of topic to talk about because essentially it means different things to different people. So when you think of Splunk, originally the original use cases were sort of Google search for IT data, and a lot of how it's sort of architected is actually based around that. But to a lot of people it's also a log aggregation tool or a data visualization tool if you're, say, into visualizations. But to me, I tend to look at it more like it's a data platform with app creation sort of capabilities. It does have a proprietary search language called SPL, but it's extensible, so you can actually create your own sort of search commands if you really want to. But the actual language itself enables the correlation of your structured and your unstructured data sources, and that's where you sort of build value, in my opinion. And obviously it's got the visualization capabilities, so out of the box, and also some modular ones. So it's a pretty new feature. Recently you can now develop visualizations that hook directly into Splunk and essentially visualize all your data science-y sort of things if you really wanted to. So I'm going to try and go straight into some internals about Splunk, simply because of the semantics of actually how it works. But so you're taking your data sources and you're basically forwarding your data into an indexing farm as such, and namely within the indexing farm there's a pipeline. It does numerous things, but namely there's the line breaking and the timestamp recognition that you have to configure when you're configuring it. Following that, Splunk does data segmentation on your data, which basically means it breaks your data up using punctuation heuristics into keywords, and it squirrels it away in what they call buckets in Splunk. And those buckets then live inside an index, which is basically like a data container where you can basically delegate access if you really wanted to. So about data collection using Splunk, typically, historically, everyone's been using Splunk forwarders for years right now. The best practice mechanism of actually getting data in is file-based inputs. So what Splunk does is the forwarders, they tail your log files and forward them across. You've also got database inputs. So if you've got data squirreled away in a database that's not really visible, you can pretty much connect to it using an add-on called DB Connect. And scripted inputs. So scripted inputs are basically the Splunk forwarder actually ships with the scheduler, so you can deploy any script that you want to collect whatever data you want, really, using it. But the most important thing about actually configuring your forwarders and when you're going forward with it, with actually deploying Splunk, is to sort of deploy them as modular add-ons. And this sort of goes in with Splunk's Splunk-based paradigm, where they actually have add-ons that are reusable and can basically be shared with other users. So this is what a typical Splunk search looks like. So you've got basically like the first bit up to the first pipe is basically the search spec. And then after that you have numerous transformation commands that you use to basically size up your data like a Swiss Army knife. but essentially, the reason why I mention this is that in terms of how it sort of searches, and you're actually searching, you're actually converting what this search spec actually is up to the first pipe, and you're converting that into actual keywords. So Splunk does the automation in the background and the heavy lifting for you to sort of convert that into keywords, load that stuff into memory. So load all your raw results into memory, and then it has an in-memory pipeline on which you basically set up knowledge objects, which does data extractions, transformations, and lookups. So think of it like extract, transform, load on steroids, right? So, and then following that, it runs basically some streaming commands. So this is basically the map phase, and if you were, say, running a Hadoop cluster, it's quite similar. But that's like the map phase, and then basically your data comes back, gets reduced, you run additional commands, and then you visualize, and then you report, really. So what about knowledge objects? Why do I keep harping on about this? So essentially, the most important thing is that once you've actually got something in, you want to, and especially with Splunk where you have to pay for a license, essentially, you need to get as much value as you can out of it. What you can do is actually configure what that pipeline looks like from a web UI. And this is not typically, something that just one Splunk admin can do. This is something that you can actually federate to, all your developers and your operations teams, that they can go out and take the data and extract things as on the fly if they want to. And there's sort of common types that and common types of how they actually do that. So there's field extractions that you use regex to do, and that's a common way of doing it. And then you have field aliases that aliases your fields, and lookups that basically enrich your data on the fly, and tags and event types. So tags group things. So if you've got web logs, you tag it web, right? And then if you've got event types, you basically use keywords to formulate and categorize what your data actually is. And then eventually you have calculated fields. And that's quite powerful in my opinion, because you can commit data manipulations into the pipeline, and it'll actually do unit conversions for you. It will also do string manipulations for you, which is pretty cool. So what's the goal for doing this? So, a typical Splunk user, when he starts off, ends up sort of running a search that's this long, right? So, your typical sort of website, you're searching for, confirmations, and then you're doing multiple transformations on it. But once you've actually committed a lot of this knowledge in as, knowledge objects, it becomes significantly easier for you to search, and it becomes significantly easier for your developers to search as well. But what's another goal of this is the fact that it's actually persisting your knowledge, right? It's the fact that I can go in and implement knowledge about my data, and somebody else can come along and use that knowledge for their own benefit as well. And that brings in the sort of notion of data democratization, in my opinion. So it sounds like the holy grail of data, right? Let's set your data free and whatever. It sounds quite idealistic. But in fact, what you're really trying to do is promote collaboration between your dev and your ops teams and your security teams, and potentially your business teams as well when you're actually doing this. So the scenario in terms of how I see it in numerous businesses right now, you have microservices architectures, you've got numerous development teams under numerous service umbrellas. There's a mix of legacy systems with modern services, dependence on vendor integrations, and your data can be sensitive. So the typical data democratization issues, right? So one of them is security, yeah? So a lot of people are like, well, I want my devs to have access to all the data. Well, some of the data is going to be sensitive, right? And you're going to have to be able to deal with that. And that data itself can also be very valuable to you. And you're also talking about knowledge fragmentation. So this is the bit where knowledge objects fall by the wayside. People start committing things to Splunk, but essentially they either commit it wrong or they actually call it the wrong thing, and people don't know actually how to interpret that knowledge, essentially. And then you have adoption. So people have to like the product, right? So, people have to really like the product to actually use it. And especially if you're paying for it, you need to like it. And it shouldn't really get in the way. So in terms of your onboarding and stuff. And obviously, as you gain adoption and you've got, several hundred users on your Splunk platform, it's key that the actual platform is scalable and will scale to your business as well. And then chargeback. Now, the thing is it's a lot about data ownership now, right? So typically internally you have political wars around a lot of this stuff because no one really wants to pay for it. But what generally happens is that as long as you get all the others right, the money does come eventually. So a bit more about security. So Splunk search apps, when you log into Splunk, you have a pretty cool UI where you can basically search your data and visualize your data straight away. But what you can do with when you're sort of divvying it up for hundreds of users is divvy up your knowledge by context. So you have a Splunk search app per product or service or whatever you're actually creating, and then you also have your data access when it comes down to it. So you want to assign that sort of data access to everyone. So when you're talking about sort of security in this sort of instance, you want to have a way of that not being an administrative sort of burden to your business, right? So the way that you sort of look at it is you create federated groups. So whether it being your single sign-on solution or Active Directory, you create a federated group that you can give to your data owner. And then you map that group to Splunk roles, and the rest is magic, right? So the whole point of that is that by the end of it, you've got to a stage where you're no longer actually managing it and all your users are. So a couple of things are problems with Splunk is that when you install it first time and you've implemented it for the first time, the Splunk authentication is very, very poor. There's no real password policy or enforcement. There's no centralized management for multiple search nodes. So if you're trying to scale it out, you have to create user accounts across all of them. So what you tend to really want to do in terms of a federation exercise is get in with single sign-on. So whatever you'd want to pick out of the list, or use LDAP if it's on-premise typically. Or you can use a custom authentication method. So you can actually go out and extend Splunk to do that. But yeah, more than anything else, consider using entitlement framework on top of your federated groups. It helps with not just Splunk, but with other things. So a bit more about combating knowledge fragmentation. So the thing with sort of trying to log stuff is that you don't necessarily know what you want to log unless someone tells you. And you're not quite sure what's valuable all the time. But typically speaking, it really should be an iterative process. So there's this notion of semantic logging where you're actually trying to log for the sole purpose of analytics, right? And the whole idea is that you're going to be trying to create rich data sets that's available not just to your dev or your ops teams, but also for other business areas as well, and hopefully your data scientists later on. And then essentially when you're federating and sort of setting these sort of guidelines with your sort of developers itself is important, especially in a microservices architecture, to ensure that you actually have correlation identifiers in your data so you can actually retrieve a trace of whatever happened all the time. And it goes without saying you want to have high precision timestamps to order your data correctly. And then, yeah, like I said, you want to incorporate that into your software development cycle. Standardize your log formats, it's all standard stuff, right? But the problem with knowledge fragmentation is that not all logs can be logged semantically, or they can't be logged without significant refactoring, especially when you're dealing with your dev teams. And the Splunk solution to that are data models. So data models is a go-go gadget, is a schema on the fly. So we've already sort of noticed how sort of knowledge objects can sort of be committed centrally to the pipeline, but what data models are able to give you is a way of abstracting what those knowledge objects are into meaningful representations as a schema itself. It's basically a hierarchical structured search time mapping of your knowledge, right? So there's a bit of confusion around data models. So these days, if you wanted to check it out, you need to probably access it using the Datasets tab in Splunk 6.5. So an example. So this is basically Splunk dog fooding their own sort of their own sort of paradigm. So this is basically Splunk dogfooding their own paradigm. So when it really comes down to it, you're talking about a certain structured semantic model that Splunk gives you that you can abide to, right? So it's a shared semantic model, and you can normalize your data to look at that model. So a lot of the times people don't know what metrics do they actually need, but the CIM tables in Splunk CIM sort of enable you to sort of find out what you really need to a certain degree. So this is what they sort of look like. So you can go on their website and actually check what the tables actually look like. And this is what it actually looks like in Splunk. So as you can see, there's a field over here called process name over there for a data model called application state. You can now basically map your field name to that particular process name, and then everything just works. So all your other reporting that's actually created on top of your data model actually works as well. So to basically talk through how you actually access your data model and how you actually report stuff, there's basically a UI called Pivot in Splunk, and it basically enables you to query your structured data. It supports visualization in tables, charts, and single value visualizations, all the standard, box standard bits and pieces, really. And that's what it sort of looks like. So there's a lot of stuff in there, but to be honest with you, it takes about 30 minutes to 40 minutes to get accustomed to it, rather than actually learning a full search language, right, which takes about 1 to 3 weeks. So performance, so this is the bit where it gets quite special. So one of the problems that you have when you federate these to a lot of users, especially when it's a centralized sort of data service, as you call it, is the fact that people tend to write queries that will harm your platform in some sort of way. And they don't mean to do it, but they still would. So because you're sort of creating a structured data model itself, and it's accelerated, you're sort of decreasing that sort of search optimization effort and heavy lifting, really, in terms of accessing your data. And as a result, since everything is a search in Splunk, it also decreases your dashboard creation effort as well. But you don't get something for nothing. When you do turn on the data model acceleration, it increases your storage requirements, but it speeds everything up by about 1,000 times. Don't quote me to that, but that's some metrics out there. But typically, in the real world, what I've seen is that if you have high cardinality of data, it will actually run 3 to 4 times quicker. Low cardinality, about 100, 200 times quicker. So notable apps. So essentially, because Splunk CIM is a centralized model, Splunk is actually able to create integrations for you. So you have the Splunk Enterprise Security app and the Splunk PCI compliance app. And there's also another app called Insight Engines that basically enables you to search Splunk using natural language. So even better for federating it to business folk, really. So adoption. So most users complain about backlogs and onboarding data. You've got this stuff in, you've only got one Splunk guy, right? He doesn't really know how he's going to cope with this, right? And automating the onboarding process isn't really as easy as it sounds, because you have to validate your data before you actually put it in. So the answer to that is that you try and standardize where your log locations are, what your data looks like, and your timestamps, really. Or you can use the HTTP event collector. So this is actually quite a new functionality over the past year, where you can basically point your application to send your logs directly to Splunk, right? So if you're using Docker or something like that, whatever your application actually is, you can use the HTTP event collector, potentially a logging library that you create internally and send your data across. So yeah, I think I mentioned the logging driver. So getting to the end, no Splunk presentations complete without the new interesting features. So sort of talking about all these data and how you can actually sort of federate it. So one of the cool new features is the machine learning toolkit. It actually comes with built-in assistance for supported algorithms. They're typically, most of them are based on Python scikit-learn. You can extend those algorithms if you want, so you can write your own if you really want to, and yeah, it's pretty cool. The other thing is, and more than anything else, there's no charge on top of that. So it's whatever your data is existing, you pretty much can use that. And you've also got the ITSI integration, which is basically Splunk's take on service management itself. It's pretty cool. It's got some out-of-the-box anomaly detection features that you might want to check out. And I think I mentioned modular visualizations earlier, custom search commands, and TSIDX reduction. So if you're looking at cost comparisons, sometimes when it really goes down, storage is cheap, but when you start going into petabytes of data, you really want to be able to store it efficiently. And TSIDX reduction does that for you. It's pretty cool. Crystal ball. So, the crystal ball over here is that Splunk is always improving its offering. So essentially, what I'm generally predicting here is that Splunk is going to integrate further with the Hadoop and open source ecosystem even more than they actually have right now. They have a sister product called Hunk, which connects Splunk to Hadoop. And there's a couple of features that are already in Splunk, like Hadoop HDFS data role, where you can basically just point an index to archive into Hadoop, and you can search your stuff in Hadoop if you really wanted to. So yeah, that's me.